Z1 is equal to 2 plus 2i is expressed here in Cartesian or rectangular form. It may also be expressed in polar form as Z1 is equal to 2 root 2 cos pi by 4 plus I sine pi by 4. Now let's just explain where that comes from. So if we have real and imaginary axes like so, and let's say that 2 plus 2i is just here. So we know that this length is 2 and this length is 2 because, of course, the point is at 2, 2. And this is a right-angled triangle. And more than that, it's a right-angled isosceles triangle. So this angle is 45 degrees or pi by 4 radians. We can work out the length of the vector representing the complex number using Pythagoras' theorem. It's going to be the square root of 2 squared plus 2 squared, which is root 8, which is root 4 root 2, or 2 root 2. So this length is 2 root 2. If we didn't have those as both being 2, then using ordinary right-angled triangle trigonometry, we would know that this length here was the adjacent, and we could work out its length by calculating 2 root 2 cos pi by 4. This length here could similarly be calculated, since this is the opposite, as 2 root 2 sine pi by 4, which would make the complex number 2 root 2 cos pi by 4 plus I times 2 root 2 sine pi by 4. And then we could factorize out the 2 root 2 and we would get this expression here. This is often contracted to Z1 is equal to 2 root 2 cis pi by 4. So the cis, CIS, stands for cos plus I sine. In the same way, Z2 is equal to negative 3 plus 4i can be expressed as Z2 is equal to 5. Remember, that's the modulus of this complex number. Cos 2.21 plus I sine 2.21. Remember, the argument was 2.21 radians. And of course, that can be contracted to Z2 is equal to 5 cis 2.21. Converting between the two forms is an important skill which is tested often